All right, here we go. 2.8 inverse functions part 2. What's an inverse? It's a what?
Opposite.
No. It's a what? Switch in x and y. All right, Robert's going to start reading. Here we go.
If f and g are inverse functions, then g of x equals f of negative 1 x.
F inverse of x. Yep.
Sure. If xy is a point on the graph of f of x, then yx is a point on the graph of g of x.
All right, Lucas, take it over.
Okay, with inverse functions, all the x and y values are switched. So the graphical behaviors in terms of x and y will also be switched. For example, the domain of f is the range of f inverse.
Good.
A continuous function will only have an inverse function if it is strictly increasing or strictly decreasing. If a function changes from increasing to decreasing or vice versa, it will not pass the horizontal line test, and its inverse relation will not pass the vertical line test as a result.
All right, fantastic. To be a function, it has to pass a what test? Vertical line test. All right. And so what's an inverse again? It's a what? A switch in x and y. And so if we switch x and y, the function also has to pass the what test? The horizontal line test. All right. To have an inverse. All right. To have an inverse, it has to also pass the horizontal line test. All right. So example 1, Lucas, keep going. You're doing great.
All right. Let f be a continuous function with selected values in the table below. Let g be the inverse of f, such that g of x equals f inverse x. Find the following values if possible.
All right, perfect. So the first one, we have a composite of f of 0. And so the first thing we need to do is find f of what? 0. And so what is f of 0? 1. And so now we need to find f of 1. And so now we look at our table, and what is f of 1? Negative 1. All right, and so now we get that. All right, so now let's look at part B. And so we have g of negative 3. Well, what in the world is g? G is what? F inverse. All right, and so I sometimes like to say f inverse of negative 3 because g is nowhere to be found on this, and so I always kind of practice the notation that way. Now, I'm going to show you what I call the ordered pair method, and you can use it if you'd like, or you don't have to. I really don't care after we do this of how we think about it. And so I need to find f inverse of negative 3. And so what's an inverse? It's a what? A switch in x and y. And so of my f value, negative 3 would be my what? My y. And so I have f of x here. I don't have f inverse. And so I'm looking for when the y is what? Negative 3. And so when is the y negative 3? 4. And so then I'd find f of 4 is equal to negative 3. So f inverse of negative 3 is 4. All right, and so I call that the ordered pair method. You don't have to use it, but that's a good organization tool. If when we go over these, sometimes we think about it that way. All right, so this one, I have g of 6, and so g is really what? F inverse. And so I'm finding f inverse of 6. So am I looking for the x or the y? The y. And so when is y 6? At negative 3. And so f inverse of 6 is negative 3. All right? Because what's an inverse? It's a what? Switch in x and y. All right, let's look at this one. So now we have g of negative 1. And so really this is doing an f inverse of negative 1. And so the first thing we need to do is find f inverse of negative 1. And so am I looking for the x or the y at negative 1? The y. And so when is the y negative 1? At 1. All right. And so now we end up finding f inverse of 1. And so when I look here, am I finding the x or the y at 1? The y. And so when is the y 1? At 0. And so g of negative 1 is 0. All right, let's do it again. This one's a fun one. And so now I do f inverse of f of negative 2. Well, what do I need to do first? Find f of negative 2. And so what is f of negative 2? 3. And so now I need to find f inverse of 3. And so am I looking for the x or the y when it's 3? The y. And so when is the y 3? Negative 2. And you're like, what? What happened? What happened was, think about it this way. what's the inverse operation of addition? Subtraction. What's the inverse operation of multiplication? Division. Those cancel each other out, yeah? And so the inverse operation of a function is its what? Its inverse function. All right? And so if I inverse function, the original function, you're going to be stuck with what you're substituting in. Does this make sense? All right? And so they're inverse operations of one another. All right, let's look at f. So now I find f inverse of negative 3. And so what is f inverse of negative 3? Am I looking for the x or the y value at negative 3? The y value to be negative 3. And so then I'd get what? 4. All right. Lucas, keep going. You're doing great.
All right. Example 2. The function k is defined over the interval -4 to x is less than or equal to 11, as shown above. Let k inverse represent the inverse of k. What is the minimum value of kx? What is the minimum value of k inverse x?
All right, beautiful. And so this one's saying, what is the minimum value? Okay, so a value has to do with the what? The x or the y? The y. And so what is the minimum value of k of x? Well, k of x is given to us. So I'm looking for what? The lowest y value. And so what's the lowest y value on this graph? At negative 3. And so my minimum is negative 3 of k of x. Now it's saying, what is the minimum value of k inverse? Well, normally a minimum value is the y value, yes? However, if it's asking about an inverse, well, what are we looking for now? The lowest what value? The lowest x value. Because an inverse is a what? Switch in x and y. And so now I'm looking for my lowest x value. Okay? And so now what are we looking for? It's at what? Negative 4. All right? Pretty good there? Cool. Let's do it again. And so now I'm finding k inverse of 6. So k inverse of 6. I'm going to do this one ordered pair style, and then you can do whatever you want after this. All right? So k inverse of 6 is really finding what of k? Again, an inverse is a what? Switch in x and y. And so the y value of k will be 6. Yes? And so when I look at this graphically, I'm looking at k, and the y value is 6. So when is the y value 6? At what? 11. All right? And so k inverse of 6 is actually 11. All right? So that's how we can kind of think of it graphically. All right? So this one is k inverse of 4. And so what is the k inverse of 4? When I'm looking for what? When the y of k is what? 4. And so when is the y of k 4? At 6. So k inverse of 4 is equal to 6. Because it's right up here. Now, what if I ask, what is k of 4? What would k of 4 be? -1. It's right there. All right. And so that's just the normal one. But an inverse is a what? A switch in x and y. All right. Keep moving.
Function f is defined over the interval -2 to -8 as shown above. Let the inverse of f represent the inverse of f. What is the maximum value of the inverse of f?
All right, fantastic. So the maximum value of what? The inverse of f. All right, and so am I looking for the maximum y value or the maximum x value if we're talking about the inverse of f? The x, because normally it'd be the what? The y, but now it's the inverse, so it's the maximum what value? The x. So what is the maximum x value? 8. All right. All right, let's keep going. And so now we're going to find f inverse of 3. And so when we find this, we're looking for when the y value of f is 3. And so when is the y value of f 3? At 2. And so f inverse of 3 is 2. All right, let's keep moving. And so now we're going to find f inverse of 1. And so what are we looking for here? When the y value of f is 1. And so when is the y value of f 1? At 3. All right. Part C. So what is the domain of f inverse? And so the domain of f would be in terms of what? X. And so the domain of f inverse is actually the y's. All right. And so now this would be what? From what? -3 to 7. And so the domain of f inverse would be -3 to 7. Again, because what's an inverse? It's a switch in x and y. All right. Now, if I wanted to, let's go further. What is the range of f inverse? What is the range here then? It'd be -2 to 8. All right. All right, pretty good there? Cool. Let's keep moving. All right, and we're going to save this one for the birthday girl, Kefa. Here we go.
The function g is defined over the interval -3 is less than or greater to x is less than or greater to 10 as shown above. Let g inverse represent the inverse of g. Values of the increasing function h are given in the table above for selected values of x. Find the following if possible.
All right, fantastic. So the first one we have g of h of 6. All right, so what do we need to find first? H of 6. Well, what is h of 6? 10. All right, and so that's just a normal one. And so now we have g of 10. And so g of 10, do I have any inverses or anything going on? No. And so g of 10 would just be what? -1. All right. And so those were more of a composite function before, just with inverses soon. All right. And so let's look at part B now. So now I have g inverse of h of 0. So what do we need to do first? H of 0. And so what is h of 0? It's 3. And so now we're finding g inverse of 3. And so what am I looking for when the y value is 3? And so now looking at it graphically, when is the y value 3? At what? At 4. And so g inverse of 3 is 4. All right. All right, let's look at the next one. So now I have h inverse of g of 8. All right. And so what do we need to do first? Find g of 8. So I look at my little graph, and what is g of 8? 0. And so now I find h inverse of 0. And so what am I looking for when the y is 0? And so when is the y 0? What is it? -1. All right, because it's right there. All right, and so now this last one, we're finding h inverse of g inverse of -1. And so the first thing we're going to do is find g inverse of -1. And so what am I looking for when the y value of g is -1? And so what is g inverse of -1? 10. And so now we're needing to find h inverse of 10. And so there I need to look for what? When the y value of h is 10. And so when is the y value of h 10? At 6. All right. So we've talked about things analytically or algebraically. Now we've talked about it graphically and numerically and verbally even. So what's an inverse? It's a what? Switch in x and y.